Okay, starting with number 41. Number 41 says the function f is given by the log base 3 of x. Which of the following could be the graph of the inverse? Let's remember that the inverse of a logarithm is going to be the exponential. I'm going to change this into y equals. You can use f of x equals if you want to. And so we're looking for the graph of y equals 3 to the x. I'm plugging a couple of numbers really quickly, like for example, if I plug in 0, 3 to the 0 power, anything to the 0 power is 1, and 3 to the first power would just be 3. So I'm looking for an exponential graph. Remember that an exponential graph has a horizontal asymptote on it, so it's going to look a little bit of something like this. So I can go ahead and take out answer choices A and D, and then I just need to check a couple of points on B and C. So on B it looks like we go through 0, 1, but then at 1 it looks like we're going through the point 1, 2. So this is probably the graph of 2 to the x instead of 3 to the x. Let's check on C. C is 0, 1, and then 1, 1, 2, 3, and there it is right there. C is going to be our graph of 3 to the x, and again 3 to the x because it's the inverse of that logarithm. So 41 is going to be answer choice C. All right, 42, we've got the function f is an increasing function such that every time an output value increases by 1, so let me kind of make a little chart here of in and output. So output is going to increase by 1. Our input values are going to multiply by 4. So input values are multiplying by 4. All right, so that's going to give me a function that is a product sum pattern. It asks me which of the following could define f of x. I know that a product sum pattern is going to be a logarithm, and since we're multiplying by 4, that's going to be a log with a base of 4. So our log base 4 of x on 42 is going to be answer choice D. All right, on 43 it says to let k, w, and z be positive constants. Which of the following is equivalent? So they're testing our knowledge of our logarithm properties here. Remember that when we have things being multiplied together, we're going to take those apart using addition. Anything that comes from the bottom, we're going to be subtracting, so anything that comes from the denominator is going to be negative. I'm going to write these just as logs rather than log base 10. You can see that our answer choices still have that log base 10 in them, but I'm just going to write this as a log, and I'm going to take that k and that z apart using addition, and then I'm going to take the w squared apart using subtraction. So you can go through and write all the little 10s in there if you want to. All right, and then finally on this end, I'm going to use that little magical power that we used in the last video, that when you have a logarithm, we'll let an exponent move to the front of your logarithm. So that's going to be the log of k plus the log of z, and then I'm going to move that 2 down to the front and have the log of w. So log of k plus log of z minus 2 log of w is going to be answer choice B for number 43. All right, on 44, we're solving a logarithm equation. Remember that you can't ever take the logarithm of a negative, so at the end of this question, if we have answer choices that are positive and negative, the negatives cannot be included because of our asymptote on our logarithm graph. On our logarithm graphs, we have an asymptote right here on the y-axis. So all of our x values that we plug in have to be positive, especially if there's nothing being added or subtracted. In this case, there's not. All right, let me start by doing a little condensing first. These are subtracted. So I'm going to say that's the same thing as the natural log of x cubed divided by x equal to 4. And then this is like x to the first power. I'm going to go ahead and subtract my little exponents right there and say that that's x squared. So the natural log of x squared, which is equal to 4. All right, I'm going to now use the inverse. So earlier when I used the inverse, I used my little base number right here. A natural log is an implied base of e. So I'm going to use e, and I'm going to raise all of this and this up into my exponent of e. And since those are inverses of each other, my e and my natural log can cancel each other out. So that's going to give me x squared is equal to e to the fourth. And remember that e is now the base of my exponential, where I have that little 4 right there. All right. To get x by itself, I'm going to take the square root of both sides. When I take the square root, again, I'm going to get a plus or minus, and I'm going to say that the square root of e to the fourth is going to be e squared, so kind of like x to the fourth. The square root of that would be x squared. E would work the same way. But again, because I'm going back and plugging it into a natural log, if I plug in negative e squared to that natural log, I would end up with some domain issues right there. E is just a number, so I can say that that's my answer right there, but I need to just use the positive version. So on 44, my answer is C only. Okay, on 45, which of the following is the inverse of this function that we're given here? All right, again, an inverse is going to be a switching of x and y. Let's go ahead and make this one y so that we have something to work with. So I'm going to switch those and say that's x is equal to 4 log base 2, and I'm going to switch my x and my y, so y plus 3 and minus 1. And the first thing I'm going to do is get that y by itself. Or the first thing I did was switch x and y. Now I'm going to get y by itself. All right. Looks to me like we're kind of maybe keeping a 1/4 on those, or dividing by 4 if you look at your answer choices. So I'm going to say that that's x plus 1 when I move my minus 1 over to the other side. And I'm also going to go ahead and divide by the 4 and get that logarithm just completely by itself. But make sure you're really careful with the algebra on that. And you move the 1 over first and then divide by the 4. All right, let's use the inverse of my log base 2. So my inverse of my log base 2 is going to be to put a 2 right there and let all of that go into the exponent of my 2 so that those will cancel out, leaving me with y plus 3. So that's going to leave me with y by itself if I do 2 to the x plus 1 divided by 4 power, and I'm going to subtract that 3 over to the other side. So on 45, D is the correct answer. All right, on 46, we're talking about the log base 3 of 81. Let me write it over here just so I have a little bit of room to work with that. Log base 3 of 81. It wants to know which of the following is also true. So we're not trying to solve on this one. We're just trying to see which one of these answer choices this thing is equivalent to, basically. All right, we'll notice over here that we're working in exponentials. So I'm going to kind of change all of this into an exponential. So I'm going to raise all of that up there into the exponent of a 3. That's going to give me 3 to the m power right there. And then I'm going to let my 3 and my log base 3 cancel each other out. And that's going to leave me with 81. So I'm going to change that from a logarithm into an exponential, and that's going to give me answer choice B for number 46. All right, 47 uses our change of base formula. It says we're looking at the function f given by the log base 2 of x. We want to know which of the following is equivalent to f at 7. So f at 7 is going to be the log base 2 of 7. And what they've given us here is choices that use my change of base formula. So the change of base formula says that we can change this logarithm into any base as long as this number that's written bigger is kind of in the numerator, and this number that's written smaller right here, this base number, is in the denominator. So this one's going to be answer choice D, where they've changed this into a log base 3 on this one, and that 7 is in the numerator and that 2 is in the denominator. Just be careful that you have the logarithm written twice, so that's what made A not the answer. My numbers are switched on this one, and on this one we got all kinds of issues. We got a 10 kind of hanging out over here. They made the 7 into a base. C is kind of a mess right there, so D is going to be the correct answer. All right, on 48, we're given our function h of x is the log base 3 of x. Which of the following is equivalent to this expression right here? So let's go ahead and jot down that I'm finding 2 times, and then I want to do h at w, so that'll be the log base 3 of w, plus h at p, so that'll be the log base 3 of p. All right, and they want us to use our properties, our logarithm properties again. I'm going to use that magical power I was using a minute ago kind of backwards. So I'm going to go ahead and let that move that 2 up there into my exponent. Gives me w squared. And then I can condense addition using multiplication. So that's going to be the log base 3 of w squared times p. So w squared times p is going to give me answer choice C on number 48. All right, on 49 it tells me the function g is given by my little function that I have right there, my logarithmic function, where a, b, and c are positive integers. Which of the following is an equivalent representation? I think, again, they're just testing our knowledge of this magical property that takes that number that's in front and moves it up and lets it be the exponent of my logarithm. So that would be the log base b of c to the a power, which is answer choice A. All right, and then the last one for this video, it says the function f is a logarithmic and has points that are 2, 1, and 4, 2 on the graph. Which of the following could define f of x? Let's just kind of take and plug these little points in right here. Let's start with a. So on a, I'm going to have the log base 4 of 2. That's going to be my x value right here. This is like an x or an input and an output, and an input and an output. So this is asking me 4 to what power would give me 2? I would say I would need to take the square root or raise it to the 1/2 power to give me 2. So the log base 4 of 2 is going to give me 1/2, not 1. So it's not going to be answer choice A. All right, let's try B. On B, I've got 2 times the log base 2 of 2. Let's see here, the log base 2 of 2, anything that has the base and that number the same is just going to be 1, so that'll be 2 times 1, which gives me 2, not 1. So it's not going to be B. Let's take that one off. All right, so we know it's not A, we know it's not B. All right, let's try C. On C, I would have 2 with the log base 4 of 2. We just said the log base 4 of 2 up here is 1/2, so 2 times 1/2 does give me 1. Okay, so we're in good shape already. And then let's try the log base 4 of 4. So the log base 4 of 4, anything with the base of itself there, is going to be 1. 2 times 1 does give me 2. So it looks like C is going to be our answer choice. Let's go take a look at D just for a second, just so you can see. On D, let me start with the 4 right here. That would give me finding the log base 4 of 4 plus 2, so 6. I'm not going to do the log base 4 of 6 in my head, so that's what tells me that D is not the correct answer choice, and number 50 is C.